Bearings are used, from a small supermarket trolley to huge power plants. A number of light-duty, as well as industrial equipments, could not function without the use of bearings. A bearing is a machine element that constrains relative motions and used to reduce the friction between moving parts. For an example, a sliding door. The door cannot be lifted or removed from its place until your door works like this. It only permits sliding to open it. The possible movement is restricted to sliding motion by bearings. They are easier to move, and when friction is reduced, speed and efficiency of an object will be enhanced. Different types of bearings are used for various applications, such as rolling element bearing, plain bearing, fluid bearing, magnetic bearing, jewel bearing, and flexure bearing. But first, let we know about what is the purpose of bearings. The main purpose of bearings is to prevent direct metal-to-metal contact between two elements that are in relative motion. This prevents friction, heat generation, and ultimately, the wear and tear of parts. It also reduces energy consumption, as sliding motion is replaced with low-friction rolling. They also transmit the load of the rotating element to the housing. This load may be radial, axial, or a combination of both. Rolling element bearings contain rolling elements in the shape of balls or cylinders. We know that it is easier to roll a wheel than slide it on the ground, as the magnitude of rolling friction is lower than sliding friction. The same principle is in work here. These bearings are used to facilitate the free movement of parts in rotational motion. Rolling elements carry the load without much friction, as the sliding friction is replaced with rolling friction. Rolling element bearings can be subdivided into two major types: ball bearings and roller bearings. Ball bearings are one of the most common types of bearing. It consists of a row of balls as rolling elements. They are trapped between two annulus-shaped metal pieces. These metal pieces are known as races. The inner race is free to rotate, while the outer race is stationary. Ball bearings provide very low friction during rolling, but have limited load carrying capacity. This is because of the small area of contact between the balls and the races. They can support axial loads in two directions besides radial loads. Depending on the application, different types of ball bearings are available to choose, such as deep groove ball bearings. This is the most widely used ball bearings. Trapped between the two races is a ring of balls that transmit the load and allows rotational motion between the two races. The balls are held in place by a retainer. They have very low rolling friction and are optimized for low noise and low vibration. Angular contact ball bearings. In this ball bearing, the inner and outer races are displaced with respect to each other along the bearing axis. This type is designed to handle greater amounts of axial loads in both directions, in addition to radial loads. Self-aligning ball bearings. This type of ball bearing, the inner ring has deep grooves, similar to deep groove ball bearings, followed by two rows of balls and the outer ring. The outer ring has a concave shape, and this grants the inner ring. Thrust ball bearings. It consists of two bearing discs with raceways for the balls. These bearings exhibit low noise, smooth operation, and are capable of high-speed applications. Roller bearings maintain accurate alignment of every part over a long period of time and can carry the heavy momentary load. This renders them suitable for machinery, which requires frequent start and stops. Rolling makes the line contact with their races, while balls make point contact. It has a higher load carrying capacity. Roller bearings contain cylindrical rolling elements instead of balls as load carrying between the races. In roller bearings, there are also various types, such as cylindrical roller bearings use line contact between the rolling elements and the raceways, which optimizes the distribution of stress factors at the point of contact. This cylindrical roller bearings have a very high radial load rating. Depending on the design, They may also be able to transmit a limited amounts of axial loads. Spherical roller bearings. These bearings are very robust and work on the same principle as self-lining bearings, with the exception that they use spherical rollers instead of ball rollers, allowing higher loads to be supported. Spherical roller bearings are suitable for absorbing high radial loads and moderate axial loads. The tapered roller bearings contain sections of a cone as a load-carrying element. These rollers fit between the two races that are also sections of a hollow cone. If the races and the axes of rollers were extended, they would all meet at a common point. Tapered roller bearings are designed to handle higher axial loads besides radial loads. Needle roller bearings are a special type of cylindrical roller bearings which contain long, thin rolling elements. Needle roller bearings have a high load rating and are only suitable for radial forces. A plain bearing is the simplest type of bearing. It usually only consists of a bearing surface. There are no rolling elements. Plain bearings are used for rotational, sliding, reciprocating, or oscillatory motion. The bearing remains fixed while the journal slides on the bearing's inner surface. The bearing is basically a sleeve mounted on the shaft and fit into the bore. Plain bearings are inexpensive, compact, and lightweight. They have high load carrying capacity. It is used extensively in applications in the agriculture, automotive, marine, and construction industry. Fluid bearing is a special type of bearing that relies on pressurized gas or liquid to carry the load and eliminate friction. These are used to replace metallic bearings where they would have a short life, in addition to high noise and vibration levels. These bearings are used in machines that work at high speeds and loads. While the initial costs are higher, the longer lifespan in tough conditions makes up for it to run longer time. Magnetic bearings use the concept of magnetic levitation to hold the shaft mid-air. As there is no physical contact, magnetic bearings are zero-wear bearings. There is also no limitation on the maximum amount of relative speed which it can handle. Magnetic bearings can also accommodate some irregularities in shaft design, as the shaft's position is automatically adjusted based on its center of mass. A jewel bearing is a plain bearing in which a metal spindle turns in a jewel-lined pivot hole. The hole is typically shaped like a torus and is slightly larger than the shaft diameter. The jewels are typically made from the mineral corundum, usually either synthetic sapphire or synthetic ruby. Jewel bearings are used in a range of industry applications and in precision instruments where low friction, long life, and dimensional accuracy are important. Their largest use is in mechanical watches. A flexure bearing is a category of flexure which is engineered to be compliant in one or more angular degrees of freedom. Flexure bearings are often part of compliant mechanisms. They serve much of the same function as conventional bearings or hinges in applications which require angular compliance. However, flexures require no lubrication and exhibit very low friction. Flexure bearings are simple and inexpensive. They are also often compact, lightweight, and are easier to repair without specialized equipment. Flexure bearings have the disadvantages that the range of motion is limited and often very limited for bearings that support high loads. I hope I've covered everything about bearings. If you still think I've missed any of the bearings, so please let me know in the comments. Press the like button if you want more content like this. If you found this video useful, then please share it with your friends. Subscribe to the channel and press the bell icon to get the notifications of our new videos.